Ahmednagar. Ahmednagar. Today we will discuss on interference and system capacity in mobile communications. The contents of today's lectures are introduction of interference, type of interference, one of the problem we are seeing capacity, and detail about the core channel and adjacent channel interference. The interference occur when two waves that left one source and traveled by different paths arrived at a point. This happen very often in high frequency. In cellular radio system, the interference takes place. See here, in cellular communication, we are operating on high frequency signal, that is micro signals, and whenever the micro signals are operated, that times may be the possibility of interference occur. That interference will differ with respect to the area wise. In a city area, that is the interference are more as compared to rural areas, okay, due to the number of base station, number of subscribers. Okay, next, these are the sources of interference. These are the following orders. These are the sources of interference. Same mobile unit used in a same cell, call in progress in neighboring cell, other base station operating the same frequency band, any other non-cellular radio system which certainly leaks energy into the cellular frequency band. And whatever the effect occurs due to this interference is that maybe the crosstalk occurs whenever the communication is established. Sometimes missed and blocked calls are more due to this interference, okay. And depending on the sources of interference, the types of interference are classified as self-interference, multiple axis interference, co-channel interference, adjacent channel interference, and near and far end interference. We detail seen this all interference. Self-interference, it is due to the interference induced among the signals that are transmitted from a shared transmitter. The amount of interference induced depends on the modulation type. Different type of modulations used in a communication, cellular communication, mobile communication. Due to that modulations, self-interference occur. Next one, multiple axis interference. It refers to the interference induced among the transmission from multiple radios, means frequencies using the same frequency resources. From the same base station, number of frequencies are generated, and due to that frequency also interference caused. Adjacent channel interference. It occurs in a frequency channel when unwanted energy, frequency or radio, both terms are same. Radio channel, when unwanted energy from channels adjacent to it falls into its desired bandwidth. See here, adjacent channel frequency enters into the desired bandwidth. Due to that problem, due to that frequency, the interference will be caused. So such type of interference is called as adjacent channel interference. In next PPTs, we are detailed see the adjacent channel interference. Next, channel interference, similar with the adjacent channel interference. It will arrive at the mobile unit from other cell sites if the system is not desired properly. Mobile unit initiating a call on a control channel in a cell may cause interference with the next control channel at another cell site. The filter with a sharp fall-off slope can help to reduce all the adjacent channel interference. No doubt, we are using the filters to minimizing the interference, but some unwanted frequency also pass through these filters, and due to that unwanted signals, interference will be caused. Such type of interference called as next channel interference. Co-channel interference, it is denoted by capital CCI. In previous next PPT, we can see detail about this co-channel interference, how we can eliminate that co-channel interference also. Here we are just little bit discuss about co-channel interference. When interference occur in the cells having same channel set, it's called co-channel interference. To reduce it, the co-channel interference have to be separated by sufficient amount of distance. अगर आपको co-channel interference कम करने का है, तो आपको दो चैनल के अंदर डिस्टेंस रखना पड़ेगा. And with the help of that distance, we can minimize that co-channel interference also. That's co-channel interference also named as neighboring channel interference. Neighboring channel means जो उसके बाजू का जो सेल साइट है, उसके सेल से भी जो सिग्नल्स फ्रीक्वेंसीज ट्रांसमिट हो रही है, उससे भी जो इंटरफेरेंस होगा, उसको हम कहेंगे नेबरिंग चैनल इंटरफेरेंस. द चैनल विच आर सेवरल चैनल्स, okay, from the next channel will cause interference with the desired signal. A fixed set of serving channel is assigned to each cell site. If all the channels are simultaneously transmitted at one cell site antenna, a sufficient amount of band isolation between channels is required for a multi-channel combiner to reduce intermodulation products. See here how we can minimize that interference by using the band isolation between the different channels. Okay, because some fixed channels are allotted for the one base station, and at a one time suppose all channels are transmitting same frequency, and that due to that actions maybe the interference will be caused. Okay, next interference, near end and far end interference. See here, near end means and far end means the subscriber which is closest to the base stations, and some subscribers are apart from the base stations or tower we can say. इन वन सेल, अगर एक सेल की हम बात करेंगे, यहाँ पे दो एग्जांपल लिए हमने, एक सेल और दूसरा एक लिया है टू सेल सिस्टम. दो सेल के अंदर एक सिस्टम को रिलेट कर रही है और उसमें अगर कुछ इंटरफेरेंस के, दैट इज कॉल्ड इन टू सेल, दे बोथ इंटरफेरेंस आर नेम्ड एज नियर एंड एंड फार एंड इंटरफेरेंस. द क्लोज इन मोबाइल यूनिट हैज अ स्ट्रॉन्ग सिग्नल विच कॉजेस एडजेसेंट चैनल इंटरफेरेंस. In this situation, near end and far end interference can occur only at the reception point in the cell site. In cell of two systems, the frequency channel of both cells of the two systems must be coordinated in the neighborhood of the two system frequency band, and the situation can be seen in two cell systems. With the help of this picture, with the help of this figure, we can understand the near end and far end interference. We already say in one cell, suppose the two subscriber, A subscriber, B subscriber. A subscriber has nearest to the cell site and B subscriber are far from the cell site. But if both subscribers are provided high power transmitted signal, then near end far end interference will be created. Same situation in two system cells. If cell site A subscriber receives the signal from cell site B, then again also interference will be created due to this two cell system cells. Okay, with the help of this figure we can understand near end and far end interference. Means अगर नजदीक का सब्सक्राइबर रहा तो उसको आपको कम लेवल से फ्रीक्वेंसी ट्रांसमिट करनी है एज कंपेयर टू अगर वो सब्सक्राइबर बेस स्टेशन से काफी दूर है. नो डाउट दिस ऑल एक्शन विल बी कंट्रोल बाय द बेस स्टेशन. इट इज इंटेलिजेंटली बिकॉज बेस स्टेशन विल find out the distance between the subscriber and antenna, and with respect to that distance base station will provide the transmission signal to that subscriber. Okay, with the help of this PPT we can calculate the capacity of the system. If someone not sees my previous PPT, so please see the previous PPT on cellular concept fundamental. In that PPT we are discussing the how to calculate the capacity, how to know about the cluster size, that all. If we are find out the system capacity, that time we must know about the cluster size, cells in that cluster, and by using that given data we can find out the system capacity also. Okay, next, that is we already said that we can discuss about the co-channel interference. See, this is the structure of co-channel interference. That figure I had taken from the Rappaport wireless mobile communication books by Rappaport. Okay, from that book I take this figure. See here, these are the different co-channel cells in that particular system, and this is 7 cell cluster. Okay, but in that they are maintaining the proper distance between the two cells. If the cell site not maintaining the proper distance between these two channels, two cells, then maybe the possibility of co-channel interference occur. Okay, that interference we can minimize by using the distance and radius of that cell. Okay, see here, frequency reuse implies that in a given coverage area there are several cells that use the same set of frequency. These cells are called co-channel cells. हमने पहले ही बताया है कि यहाँ मोबाइल कम्युनिकेशन फ्रीक्वेंसी रीयूज टर्म यूज की जाते हैं. ड्यू टू दिस टर्म्स the same frequency set are used by the another cells. Okay, and due to that frequency reuse pattern, whatever the interference will be created, that is called co-channel interference. Co-channel interference cannot be combated, means cannot be eliminated cannot be eliminated by simply increasing the carrier power of transmitter. हम सिर्फ कैरियर पावर इंक्रीज करने से हम को-चैनल इंटरफेरेंस डिक्रीज नहीं कर सकते. This is because an increase in carrier transmit power increases the interference to neighboring co-channel. अगर कैरियर पावर आप इंक्रीज करते तो आपको को चैनल इंटरफेरेंस में भी प्रॉब्लम हो सकता है ड्यू टू दिस carrier power transmission, because that is near end and far end interference will be occur. Interference can be reduced by separating the co-channel cells physically by a minimum distance. This interference we can minimize by maintaining the proper distance between the cells. Okay, when the size of each cell is approximately the same and the base station transmits the same power, the co-channel interference ratio is independent of the transmitted power and becomes a function of the radius of the cell and the distance between the centers and nearest co-channel cells. With the help of the distance and radiance, we can find out the Q parameter, that is co-channel reuse ratio. That Q we can find out by D by R ratio, and in terms of cluster we can find out that is under root of 3 by n. Okay, with the help of this factor we can maintain the co-channel interference in a given system. Okay, next we are explaining about the adjacent channel interference. Interference resulting from signals which are close in frequency to the desired signal, it's called adjacent channel frequency or adjacent channel interference. Adjacent channel interference result from imperfect receiver filters which allow nearby frequencies to leak into the passband. See here, adjacent channel interference किससे क्रिएट होता है? नो डाउट हमने पहले भी बताया कि सिस्टम में फिल्टर्स रहते हैं, फिल्टर का काम ही रहता है कि अनवांटेड सिग्नल इलिमिनेट करे, लेकिन उससे भी अगर कुछ सिग्नल पास हो जाते, दैट सिग्नल्स क्रिएट द एडजेसेंट चैनल इंटरफेरेंस. इट इज serious problem, can be particularly serious if an adjacent channel user is transmitting very close range to a subscriber's receivers. Okay, while receivers attempt to receive a base stations on the desired channel, this is referred to as a near far effect. Okay, see here, these are below figures, below waiver diagram we can show that adjacent channel interference, that the small lines that is denoted as receiving filter response, and the blue link and yellow links are signal on the adjacent channel. See here, whenever the filter filter the desired signal, that time unwanted adjacent signal also comes into that filter, and due to that unwanted signals, the interference will be created. In below bottom figures we can show the desired signal and interference signal after filtering the desired signal. Okay, and upper diagram shows the near far effect diagram, that is for desired signal and unwanted signals, adjacent co-channel interference signals. Here we are in left figure we are showing that some mobile are near to that base station and some mobile are far away from the base station. That part we already discussed in previous PPTs. To reduce that interference, the adjacent channel interference can be reduced by carefully filtering, carefully channel assignment. Due to these are the two main we can say remedies to maintain that interference. Okay, this is all about the today's session. I hope you all understand the interference in cellular communication or cellular concept. Okay, thank you for patiently listening my